All right, let's now talk about fiber optic cabling. So you've talked about the need of cable, what the physical connection. We've looked at copper cabling. We talked a little bit more on the UTP details. Now we're going to look at fiber. People go, well, gee, why do I need fiber? Well, fiber definitely travels a whole lot longer distances. Most of your Ethernet cables that are made with copper have like a 300-foot length definition. Any longer net system, degrades to a point you can't make a detection. So now we're talking about fiber can transmit with less attenuation. It'll go miles or thousands of miles based on the type you're using. Plus, there's nothing that will interfere with a fiber cable. Now, of course, the disadvantage is being just basically very thin pieces of glass. They're fragile. So they become, I'm going to have to use them in certain circumstances. They cost more. If the installation costs more, making repairs on it costs more. But those costs, basically, the amount of data I can get through definitely makes it worthwhile, along with no interference. Now, there are two basic types of fiber. There is a single mode fiber and a multi-mode fiber. Now, in your single mode fiber, it basically consists of a very small core, and the laser will send down a single ray of light down this core. Now, this core is like 9 microns, and then, which is thin, piece of hair thin. And then it puts a glass coating, so it puts a large protective coating around it, and it then puts a polymeric coating around it to protect the glass coating and the glass core. And single mode does a single beam, single laser, and it's used in a lot for long distance situations spanning hundreds of kilometers, such as those used for long home telephony or cable TV application. Now, multi-mode fiber, instead of using a laser, it uses LED emitters to send light pulses, but it enters the multi-mode fiber at different angles, and it just bounces longer and all over the place. It's definitely produced with a lower cost LED, so versus a laser, it's an LED, so the cost is less. And it does give me bandwidth up to 10 gigabits. And as you notice, I get about 550 meters versus if I was doing the single mode, I'm talking hundreds of kilometers. So multi-mode definitely has probably twice the range of Ethernet, maybe even a little bit more than that. About twice. So you got a glass core that's thicker. The shading's about the same, and the outside coating is about the same. But just remember, the multi-core, because it's LED and it's coming at different angles, it's going to bounce different, doesn't get the same amount of distance in it. Now, how is it used? Well, there's several different types of industries that use it. Enterprise networks will use it as backbone cabling for applications and interconnecting infrastructure devices. Fiber to home, a lot of us in the future probably will get, instead of cable TV, instead of the coax, you're going to get fiber brought into your house. It's definitely used for long haul networks that I'm traveling between countries, between cities, because I can get long distance and high speed and a lot of data that gets transmitted. It's perfect. Or submarine cable networks. The cables are buried on the floor of the ocean. I should have posted a couple of videos on how they go ahead and post those. It's kind of interesting. Now, there are different connectors with fiber. There's basically 4 different. One, you've got the straight tip connector. Now it can have a single or a dual connector. This one's got the dual connector in it. You can have the subscriber one, which says, hey, I've got 2 each individual one. It's got a square connector, widely used for the LAN and WAN connecting. It makes it easy to ensure that I got a potential intercept. You've got a loosen connector. This has similar to an Ethernet connector that allows you to hold it in place, because you want to make sure that it's smaller in size, but you still got to make sure you hold it in place. And then you get duplex, and here you got similar holding connector holding it down, but you've got 2 different cables on it. Now, since you've seen different connectors, guess what? There are different patch cords, and can just get you from destination A to different destination B, or destination A and B. Here you got your, SC to SC multi-mode. You've got LC, you've got the loosened connector, and you've got, so different patch cords, different colors, different standards, different connectors. Just know that there are some differences there. Now the question is, why would I choose between fiber and copper? Well, here you got higher bandwidth. I've got longer distances. I'm immune to EMI, RFI, electrical hazards. But the cost for the connectors and installation, safety precautions, all those are high. So it's kind of like, to get this, you got a higher cost. That's why most of our offices and homes are probably wired with unshielded twisted pair, because eventually it's going to get me that 10 gigabit speed without any of the, even though I've got a relatively short distance, that 100 meters will work very well in a lot of offices. That may mean I need switches on each floor to make sure I can handle everything, but that's a small price to pay. Now you see some buildings will actually run fiber between floors, because I got the bandwidth to handle the data and the speed, and because it's going between one floor and another, they're well protected. Yeah, it may cost me, some price to get them installed, but I get high speed. Once they're protected, I get no interference, I get nothing else, and then I can run the shorter distances this way. Because if I've got to run from a switch on the first floor to a switch on the second floor with this slow speed, that minimizes how much traffic I can handle. So just keep that in mind. So I'll let you do the check your understanding, and the next video we'll talk about wireless. Talk to you later. Bye-bye.